Okay, if you turn to page 17, 9.3, today's lesson is going to be on special products of polynomials. Now, I'm going to show you the pattern for some special products, but if you forget the special pattern, you can always FOIL. So getting familiar with these special products will help you because the second half of the chapter, instead of multiplying, we're going to be factoring. And although you can FOIL if you forget the special pattern, when you go to factor, you don't have another choice but to remember and use the special pattern. So it does make sense to try to familiarize yourself with this now. So the first special pattern we're going to use is called the square of a binomial. So a plus b squared. Now, first of all, remember that a plus b squared is not and will never be a squared plus b squared. Okay? We learned that back in chapter 8 with exponents. We learned that a plus b squared should be written out as a plus b times a plus b. Now, if you FOIL a plus b times a plus b, you get a squared first, outside, plus ab, inside. It's ba, but we can write it as ab, plus b squared last, right? The ab plus ab becomes 2ab. So it's not a squared plus b squared. That is wrong, right? Because there's always a middle term. Now, the special pattern tells you that if you memorize the special pattern, you don't have to FOIL it each time you want to use it. But foiling it is not a big deal. Now, it becomes a squared plus ab, so your middle term is plus 2ab. And your first term is a squared, your last term is b squared. So this middle term here is plus 2ab. Now, if you're doing a minus b times a minus b, your middle term is minus 2ab. And I'm showing you this now. We're going to do this a little later. Notice this is a plus b times a plus b. This is a minus b times a minus b. If you have a plus b times a minus b, when you FOIL it, you get minus ab plus ab. So the two middle terms drop out, and you end up with this as the product. And you're going to learn this is called the difference of squares. But we'll get to the difference of squares in a little bit, and that happens when the sign connecting your binomials is opposite. One is plus, one is minus. Okay, so we can erase that now. So now let's look at the example. This is x plus 4 squared. So normally you would just do x plus 4 times x plus 4. And there's nothing wrong with actually FOILing it. X squared plus 4x plus 4x plus 16. So you get x squared plus 8x plus 16. But what this special pattern is telling you is instead of actually FOILing it, you square the first, which is x squared. You square the last, which is 16. Your middle term is 2 times, that's why the 2 times a times b. So a in this case is 1, or x, sorry. B is 4. So a times b is 4x, double that, and you get plus 8x. So you see, I didn't have to FOIL it. I just used the pattern, and I got the same answer. Now for this one, you do the square of the first, 9x squared. The square of the last, 4. This is minus. This is going to be minus a times b. So that's 6x times 2 is minus 12x. So let's FOIL it and see if I'm right. 3x minus 2 times 3x minus 2 is 9x squared minus 6x plus 4. So combine your two middle terms, you get minus 12x plus 4. Okay, so again, instead of FOILing it, you say a times b, 4x times 2 is 8x to get your middle term. 2 times 3x is 6x, times 2 is negative 12x to get your middle term. So now let's try this using the special product. So I square the first, 4x quantity squared is 16x squared. Square the last, 3 squared is 9. To get the middle term, I do 3 times 4x, which is 12x, and double it. It's 24x. Okay, now for this one, square the first, 3x quantity squared, square the last, 5y quantity squared. So I get 9x squared first, 25y squared last. I do this times this, which is negative 15xy. Double it, negative 30xy. Negative 30xy. Okay, so let's try the next one together, and then you're going to try the following two on your own. So I do square of the first, x squared, square of the last, 81. The middle term is 9 times x, which is 9x, double it, plus 18x. Okay, so now you try number 2 and number 3 on your own. Do it the shortcut way, check it by foiling, and then I'll go over it. So stop the video and start it again. So now, hopefully you got this. We squared 2x. 2x quantity squared is 4x squared, because 2x times 2x is 4x squared. 7 times 7 is 49. My middle term is negative 7 times 2x is negative 14x. Double that, negative 28x. Okay, for this one, 5r times 5r is 25r squared. Square the first, square the last. The middle term is doubling this times this. 5r times s is 5rs. Doubled is 10rs. Okay, and if you FOIL it, you'll see you get the same answer. Okay, so now let's turn the page. Okay. So whoops, went the wrong way. Okay, so this is the difference of squares. Now, here, this is what I showed you before, where you have a plus b times a minus b. Notice you have the same binomial, but it's connected by different signs. Whenever you have the same binomial connected by different signs, the two middle terms are going to drop out. So you end up with a squared, but then you get minus ab plus ab, so they cancel each other out, minus b squared. So whenever you see this pattern, it's called the difference of squares. The two middle terms drop out. So in this case, I do square of the first minus square of the last. Now, if you were to FOIL it, just to make sure I'm right, you get x squared minus 4x plus 4x. So they cancel each other out, and you get minus 16. Okay, so again, can you just FOIL this instead of remembering the pattern? Of course you can, but learning the pattern now will help you in the future. So let's look here. I notice I have the same binomial connected by opposite signs. So it means the two middle terms will drop out. I just have to square the first, square the last. So this becomes n squared minus 9. Same thing, minus and plus. So square the first, square the last. I get 16x squared minus y squared. Could I get the same answer by foiling? Yes, but we're trying to learn the pattern, and this is called the difference of squares. So now this says you can use these special products to find this product, okay? This is a good exercise, but not very practical. So if you wanted to mentally multiply 17 times 23, just see if you can do it in your head instantly. Most people can't. Maybe some of you can. But I do notice that 17 is 3 away from 20 and 23 is 3 away from 20. And I'm going to use that information to help me mentally find this product. So 17 is 3 less than 20, while 23 is 3 more than 20. So instead of writing 17 as 17, I'm going to write it as 20 minus 3. Instead of writing 23 as 23, I'm going to write it as 20 plus 3. Now I notice this is the difference of squares. So I can square the first, 400, minus the square of the last, which is 9. And therefore, I know this is 391. And I could do that in my head because I can square 20 in my head. I can square 3 in my head, and I can subtract the 2. So again, not all that practical, but it's good practice. So let's turn the page. And so this says find the product. Okay, so number 4, I notice it's plus minus square of the first minus square of the last. Again, I notice it's plus minus, so square of the first minus the square of the last. Okay, and again, number 6, you guys go ahead and do it on your own. Hopefully you got square of the first minus square of the last. And then the last one asks you to use mental math. And I notice 26, well, don't know why I'm writing that. 26 is 30 minus 4, and 34 is 30 plus 4. I can do 30 squared in my head. I can do minus 16 in my head, and I get 884 as an answer. So again, is it that earth-shattering? No, but it's good practice. Okay. So you're going to do your homework and you're going to practice these special products. And again, could you get the answers by foiling? You absolutely could. But if you try to practice and learn the special products, it definitely will help you when we do 9.6. Okay, now I want everyone to turn to page 23. And we're going to go over finding the GCF. Okay, so we're just going to review how you get the GCF of different terms, right? So here we have 16x, y, z, x, y squared, z squared, 72x, y, z cubed. So the way you come up with the GCF is first you do the prime factorization of 16 and you do the prime factorization of 72. We will review how to do that. But then you write all of your variables without any exponents. Once you've done that, and again, I will review how to do prime factorization, you circle all the pairs that you can. Now, I can't circle 2 and 3 or 2 and 3, so I don't. But I end up with a 2 times 2 times 2 times x times y times z. So if I multiply that out, I get 8xyz squared. And that would be the GCF. Okay, now notice when you're getting the GCF of variables, it is always the lowest degree of each variable. So in other words, x and x, it's only x to the first. Whoops, I didn't mean to erase that. x to the first, x to the first, this is x to the first. This is y squared, but this is only a y. So you take the lowest degree, which is y. This is z squared, this is z cubed, so you take the lowest degree, which is z squared. So for variables, you always take the lowest exponent. Okay, so now let's go over a factor tree to get the prime factorization. So if I was to do the prime factorization of 16, I always start with a 2, right? If I know it's divisible by 2, I start with a 2. If it's divisible by 3, I start with a 3. I start with small prime factors. So this is 2 times 8. This is prime. I circle it. This is 2 times 4. This is prime. I circle it. This is 2 times 2. They're both prime. So the prime factorization of 16 is 2 times 2 times 2 times 2. So now 72. So I'll start with 2 and 36. I circle it. 2 and 18. I circle it. 2 and 9. Circle it. And then 3 and 3. So the prime factorization is 2 times 2 times 2 times 3 times 3. Okay. Now, to be honest with you, most of the GCFs we're going to be able to do, you're not going to have to go through that process. You're going to be able to do it in your head. So let's go down to number 9, and we're going to try to find the GCF of 15 and negative 45. So just ignore the negative and just say, what's the GCF of 15 and 45? Well, I know the greatest common factor between 15 and 45 is 15. I think most of you do, and you can do that in your head. But let's suppose you don't know, and let's do the prime factorization. So this would be 5 times 9, circle it, and this would be 3 times 3, circle it. This would be 5 times 3, circle them both. So now I line up 45, and I write 3 times 3 times 5. I write 15, and I write 3 times 5. I circle the pairs they have in common. This is 3 times 5, which is 15, which is how I got a GCF of 15. Okay, so let's do another one. Let's do number 12. Okay, now, okay, so let's do 49x. We'll do it here. Now 49x, I could do a factor tree. I don't need to. I know it's 7 times x. Okay, now I know 343x squared is going to be x times x. So I know as far as the variable goes, it's just going to be an x, because remember I told you it's the lowest power that you see. I see an x to the first, x squared. The lowest is x to the first. So I know it's going to be x to the first. Now, 343. Okay, I know 7 goes into 343. 7 goes into 34 4 times, and it goes into 63 9. So this ends up being 7 times 7. So 343x squared is 7 times 7 times 7 times x. So I circle the 7, the x. So the GCF is 49x. This GCF is 49x. And again, like I said, you probably could have done that in your head if you knew 7 cubed was 343. But if you don't, you could have figured it out. So let's do number 13. So 4a to the 7th b and 28ab. Well, first, let's do the variables. I know that it's going to be ab. How do I know that? This is the lowest degree. This is the lowest degree. So we don't even have to do that part. Now, 4 is 2 times 2. 28 is 2 times 14, which is times 2 times 7. So what they have in common is 2 and 2, which is 4. So this GCF would be 4AB. Okay, So again, I did want to go over this, but most of what you're going to do when you're finding the GCF is going to be stuff you can do in your head. So let's turn the page. And let's do prime factorization of, let's say, 8, 11, and 14. So 108, I'm going to first divide by 2 and get 54. Divide by 2 again and get 27. 27 divide by 3. Whoops, circled the wrong thing. And 3 here. So we end up having 2 times 2 times 3 times 3 times 3. So this is 2 times 2 times 3 times 3 times 3. Okay, so now stop the video and on your own do 11 and 14. And when you're done, start it up and see if you get the same answer as me. So 144, now I'm going to break my 2 rule because 144 we know is 12 times 12. We know 12 times 12 is 4 times 3 and 4 times 3. And that becomes 2 times 2 times 3 times 2 times 2 times 3. So this would be 2 times 2 times 2 times 2 times 3 times 3. Okay, and then 357. 3 plus 5 is 8 plus 7 is 15. 15 is divisible by 3, which means 3 goes in. And 3 goes in 1, 1, 9. And 119, 7 goes in. Now, if you always have to check for 7 and 11, those tend to be numbers we don't know by heart, but 7 times 17. So this is 3 times 7 times 17. So always check 7 and 11, see if that works. Okay. Okay. So that's all we're going to do with this. So we're going to go ahead and stop the video.